So it's my pleasure now to introduce Anna Halpern Lande. Anna has extensive experience in the clean tech sectors across various companies, and more recently is now at Shell as part of the senior management upstream business development, where she spearheads renewables, so to speak, the beyond petroleum efforts at Shell, if you excuse that little joke there. And Anna will talk to us about using sustainability to improve oil and gas operations and create in-country value. Anna, the floor is yours.
Thanks very much. So in essence, I'm really going to talk about looking at sustainability through a slightly different lens. And you know, historically, sustainability is something where usually you get out your health and safety people, your environment people, you get out the folks who focus on corporate social responsibility, and it's immediately a discussion on how much, you know, of course people in companies want to do the right thing, but, you know, there's a certain amount of money they have to spend, and it's a cost center. And I think that is in itself a not very sustainable way to approach it. And so what I want to talk about is, you know, that has historically been kind of a purview of not-for-profits, NGOs, environmentalists, in a way that is always viewed as not synergistic with the underlying business. And I'm here to put a slightly different view on it, which is to say, I don't know how many people remember that when GE started to head towards incorporating, you know, a green perspective, the CEO at the time said something along the lines of, "This is the best way to optimize and, you know, make our assets more operationally efficient." And so I'm going to put forward a case that actually, you know, in the best case, you are somebody who has assets. You are not, you know, just feeling the good feeling. You have a significant balance of assets, and you need to figure out how to make them more operationally efficient. And that in some cases, and not in all cases, as new innovations, sustainability technologies come down the cost curve, they're going to provide differential advantage and enable managers of commercial assets to begin to get a differentiated return and continue the growth curve that they need to show in their profits. So effectively, you need to show to your investors, to your shareholders, that we're going to get a return of 5% growth in income per year, and this is going to be one of the ways that managers are able to realize that necessary promise. And I think this is really important because it moves sustainability off the corporate social responsibility agenda and into the agenda of the business owner in a very big way, and into the agenda of the operator in a way that makes it not initially is still, you know, something new, something different, but ultimately becomes just the way that we do business. So what exactly happens? Well, this is really about optimization, optionality, looking at the opportunity, and then I want to tie it back to how we think about in-country value and what that means. So when we talk about sustainability, you need to either be working, you know, sustainability of what, right? Sustainability in general, when we talk about it in terms of what does this mean in terms of our relationship with the environment around us, with the people around us. But I think it also needs to be widened to encompass the assets that we have under management and even the sustainability of the initiative itself. And so, like I said before, you really need to be managing a significant portfolio of assets, operational assets, and or working with somebody who is. Then you need to really understand the operations themselves and the cost structure of those operations. So I'll begin to layer in some oil and gas examples. So when we look at an oil field, if you look today at some of our gas fields, which we're, you know, planning to produce for domestic gas, if you look at the life of the field, over the life of the field, two things happen. One is, if it's an oil field, over the life of the field itself becomes much more energy intensive. So you can literally plot this curve, and it shows that over time it goes up, and then there's all these sort of technologies we try to bring in to bring it down. And what that actually means is, in most cases, it means one of two things. It either means that you're buying gas to power that field, you're buying diesel for diesel generators, or, you know, you're burning your associated gas or your own gas to do that. And in some cases, that can be up to more than 10% of the reservoir itself. So that is a very significant financial hit to your business if you're burning 10% of your own reservoir to power. And if you're talking about a sour gas field or something like that, it could be 10%, it could be more. And you need to do it because a sour gas field, if you don't manage it properly, it's going to create an environmental hazard. So you need to strip out, if it's sulfur, if it's CO2, you need to strip that out, do it safely, do it comprehensively. Now, the other thing you need to think about is water is another major, so energy is one issue, water is another major issue, which over the life of the field, I don't know if people heard me earlier today, that can go from being, 1 part water to 5 parts oil, to at the end of the life of the field, 1 part oil to 10 parts water or more, and that is the case in petroleum development Oman and some of the mature fields. And that's simply because you need to maintain reservoir pressure. So to maintain reservoir pressure, you pump water down there. The water mixes with oil. The holy grail is water and oil separation down in the well, but nobody's invented that yet. If you have, please come see me. I'll be very interested to talk to you. But because they haven't, you have to pump it out. That has cost implications as well, because it means you're pumping more fluid, and then you're probably pumping it back, right? Or you're disposing it in some way. And it means you're moving a lot of fluid around, and moving fluid is extremely energy intensive and expensive. It's heavy. It's very heavy. And so you need to understand your cost structure and how that lays out. Another good example is in PDO again. We have invested in a company called GlassPoint. Some of you are aware of them. And why did we invest in them? Because when we look at that end of life period, right, we need to inject not just water, but steam to stimulate the reservoir. And steam is even more expensive than water because now it's hot water. And so now in order to heat that up, you're going to be burning a lot of gas. And in Oman, that's gas that's very precious to the country because although they have a lot of gas, they have a lot of export obligations. And so they're not exactly flush on gas, contrary to people don't usually know that. And so gas becomes extremely precious. And so the ability to save gas and repurpose it for what you might call a higher use, to take it to a different value chain, whether that value chain is they have aluminum smelters, they have fertilizer plants, or whether it's just monetizing it through liquid natural gas, through LNG, you can take it to an alternative value realization, okay? And so you need to understand your overall cost structure, but also the options that are available to you in order to make that optimization. And you cannot do that if you don't have assets. If you have no assets, you have nothing to optimize. And so the next step really, and we've already started to discuss it, is to really understand what I call the value realization levers. So just how are you going to make money? What are the key value drivers that are driving the efficiency and the value of your business? Is it the number of barrels of oil that you're pumping out and exporting? Is it the amount of gas? Is it power? Is it fertilizer? Is it, uptime in the aluminum smelter? What's the profitability of the aluminum smelter? Are they losing money fundamentally on the aluminum smelter? And what's the balance? Is it, the goal of jobs, for example? And then where is your associated gas going? Is it going for reservoir pressure? Is it enabling you to get more oil out of the ground? So really understanding what the value realization levers are available to you is critical on the upside, right? But also on a cost structure. So there, you begin to look at what are the energy needs, what are the cost drivers, what are the energy needs, what's the volume, how many megawatts or, megawatts thermal are you needing to get the oil out of the ground per barrel, and what does that picture look like, not just today, but over the horizon, the development period over of the field. And I should add, I'm talking about an oil reservoir, but you could do that for any asset that you have. And that's really important because once you begin to take this argument to the managers who are running the business, it's a real opportunity for value for them. The other thing in terms of value drivers is the other side of it is where are the costs going? So what does the transition look like? So we are in a new sort of world because if you look at the costs of photovoltaics, they're going where nobody thought they would go and faster than anybody thought was possible. Right? And so, I was just talking to the Saeed Al-Tayr, the head of DIWA, and he was saying, I've got solar coming in now, solar installations coming in at prices I never thought I'd see. And he told me the prices. I can't tell you because I don't know if I'm allowed to tell you. But they were incredible. And so what you then can begin to do is you can do two things. One is you can take care of your cost, which is you need to pump a certain amount of oil, you need to power an amine stripping facility in order to strip the sulfur out of gas, you need to have a gas processing facility, you need to have a GTL facility, whatever it is. You need to have your aluminum smelter and uptime. You need a certain amount of gas and a certain amount of power for your fertilizer plant. Could be a car manufacturing facility. But you need that power. And at the same time, you can look at the optionality that happens of what happens if I use a different power source to get it. And this begins to be very interesting because you start looking towards the future. So one of the nice things about oil is you're not talking a little bit of power. So in one of our assets, which is a shale gas resource, over the life of the field, which is the billions of barrels of oil, we are going to spend gigawatts of energy. We're going to need gigawatts of capacity. So what that means is if we're able to do, let's say, 20, 30, 40% of that with some kind of solar and storage solution, we'll actually build a very substantial renewable energy resource. And that itself creates a level of optionality that's very interesting. I mean, the other nice thing about photovoltaic, and I'm just picking that as an example because I could pick wind too, right? It just depends on where you are. And I think the other part is this assessment of what is your resource base that's available to you. Are you in a sunny place? Are you in a cold place? Are you in a windy place? Are you in a not windy place? All these kinds of things. And to then optimize for exactly what happens to be there. But that optionality, coming back to the optionality, it starts to provide you for free, another business. And that business doesn't have to be, all that business has to do is it has to be cheaper than what you're spending already for the cost, but it gives you the optionality so that, if you're running a water authority and you have to pump a certain amount of water around the place, and you're doing that with diesel generators, and now you substitute in a mixed generator and solar solution, right, for free, because you just took it out of your existing costs. You just got a bunch of solar assets. And at some point, it might not be worth your time to be pumping that water anymore, but now you're generating electricity. Hello, you've got a new business. And so there's a real value to that option. And, I can't look forward and tell you what it's going to be worth, but, I certainly can tell you that, let's say you end up with hundreds of megawatts, it's not going to be worth nothing. That's for sure. And so there's a real interesting thing that starts to happen there. The other thing is that increasingly, and I'm no expert on this part of it, but increasingly what we're seeing is that people are creating financial structures that unlock value as well. So, for example, if you're the asset owner or you're working with the asset owner, there are plenty of people that owner does not need to finance that solar or that energy infrastructure on their own balance sheet. They don't have to put up their precious capital. Oh no, there's a whole group of people in structured finance that are happy to do that. But even they don't have to put up their precious capital because now there's a lot of institutional investors who are very keen to see sort of these master limited partnerships or yieldcos who then take the assets and the power purchase agreement that the person who owned the assets set up and take that into a company and sell off the shares, sell off the dividends associated with that. So you actually have another layer of optionality around the financing to just, the gentleman from Nestle is sitting in the front row, and I'm sure he can think about which factories he has, what the power load of those are, where the peaks are, and in fact, if he's in a country where he can sell power back to the grid, he can peak shave. And so much like the German industry, he can turn himself into a little, solar generation unit and actually be generating some revenues off the power that he's using for the plant and selling back to the grid at peak. And it's actually kind of cool. And he won't even have to really pay for it. I couldn't tell him what his payback is. He'll have to figure it out himself. But he probably gets his money back relatively quickly, especially if he uses some financial structure like a yieldco. Let's say he sells half or 3/4 of the yieldco. He still maintains a dividend stream, which balances out his power purchase agreement, but he's also sold off, to institutional investors, the majority of that. And that represents very real value and real optionality. And there's a whole lot of stuff that you can do around how you structure those commercially, those agreements on both sides, to make sure that as the asset owner, you are in the driver's seat. And the bankers and the developers and the EPC folks are all around you helping you do that. But it's you who really thinks about what is the picture. And the longer your perspective, and Shell thinks on a 50-year perspective, but the longer your perspective, the better off you're going to do. Because you're going to think about, wow, wait a second, if I'm going to put in a couple hundred megawatts into the Swiss power market, what is that going to look like today? What is that going to look like in 10 years? And yes, the assets will depreciate and be written down, but probably they'll still be producing in 25 years. And that, too, is a value to it, to the operator, to the asset owner. And then I think the other thing is we see these transitions. So like I said, one of the major transitions is the cost of PV, the cost of wind, but also we're seeing now, I keep my eye out on interesting technologies, right? So actually, the PV market has not innovated that much. There's been a significant amount of innovation on operational efficiency and manufacturing and also on development. But, we're still talking about the same silicon wafer panels that, some of you may have been blessed enough around to have seen 20 years ago. And so there may still be significant amounts of innovation to come in the solar space. And so we can expect transitions there. The gas market, also we're seeing significant transitions. If you go talk to the guys from E.ON or RWE, they'll tell you, we would have never guessed 10 years ago that we would be where we are today in the German energy market. And in fact, if you look at the gas market and the transformation that's happened in Germany around the gas market, it's very hard to predict what's going to happen. But these transitions have the potential to create real and lasting value. And then finally, what are we doing with the water? So we have water inputs that we take. We have water disposal, water that we have to dispose of. And that space is also, this whole conference is about how that space is moving. And I think moving in a good way, but it means that how that is viewed is going to transform. Fingers crossed it's going to transform a lot in the next 10 to 15 years. And that means that we've got to rethink what it means around where do we source the water. One of the things that I did was, I think a lot about the Gulf. And so I started thinking, it's really bothering me. I went kayaking because I wanted to see how bad it was just off the coast for the mangroves. And in fact, it's pretty bad. The water's about a 75,000 TDS, and it's actually kind of amazing the mangroves look as good as they do because they're pretty resilient. But the salt was flaking off my arm. I literally could have just dipped my arm, let it dry, flake it off, put it in my salt shaker. Had some nice sea salt. So thinking about that, I started thinking, where could we dispose of that water? Well, guess what? I did some work. I'm not a scientist, but I went and spent some time with our technical folks, and we came to the conclusion that probably we would be able to take a significant amount of the saline brine into oil fields. And that'd be a nice place to dispose of it, because we need the water, so why should we be taking, nicer water? We should be getting rid of a problem for the country. And is the infrastructure there? No, but in theory it could be done. And so when we start thinking about sourcing water in alternative ways, and by the way, we've done an RFP for a Canadian wastewater treatment facility in South Africa. We're taking municipal wastewater into our refinery in Durban, and we're taking in Canada the municipal wastewater into unconventional field, which is being fracked. There's a lot of stuff you can do around the water, and a lot of stuff you can do around water transport, and it's really looking at the cost-benefit analysis of that. And just to give you another on operational efficiency, the team that looked in Canada spent a lot of time looking at the optimal water consistency and composition for the fracking. And what they actually figured out is, first of all, they took so the threshold water, I think it was like 50,000 TDS or something like that to begin with. They took it through ceilings that they thought would never be possible to reuse the water. So one thing that can be done is when you have fairly difficult water, you can reuse it for produced water reinjection. So you take the water, you reinject it, it means you need less makeup water. And by varying it, they also worked with a lot of other small players in the region. And those people had not thought about a number of things. They were not doing disposal in any sort of systematic way, real risk, environmental risk there. But second of all, they hadn't thought about the composition. Well, the team optimized the composition for the field. They got great field performance, but they also were able to reuse the water up to a level of salinity that nobody had ever contemplated before. And then the last thing I want to say about water is, where things are going in terms of disposal. I mean, I think we all can imagine there are today quite a bit of disposal is happening in what I would call suboptimal ways around the world. Water being disposed of into oceans or being left in tailing ponds, and across the oil industry. And I think we're going to see a world in which that's going to stop, and so we need to get ready for it. And so the more that we're able to get the water to a reusable state, that doesn't mean you can drink it. It just means that it can be used for something else, whether it's an industrial process or whether it's, let's say, non-food chain agriculture that will improve the overall environment and start creating what you might call a natural capital asset. And we've been looking very much into that and to see what do those value chains look like and who should we partner with, because quite frankly, we're not an agricultural company. We don't really want to play one on TV. But I think what's interesting about that is if you start creating non-food chain agriculture and you have a lot of local people who, may be doing food crops, maybe doing farming, because it's subsistence farming, or maybe doing farming because it's a hobby, you start to create opportunities where you want to partner with local farmers, especially if you're like us and you don't really want to do that yourself. And then you look for who would like to grow, I don't know, frankincense, or who would like to grow flowers. And you have a conversation about that, and then you start to be able to see, is this going to make some money? And if it is, then you can kind of offset your disposal costs while still bringing real value in terms of something for the local people, the local farmers, but also value in the sense that once you start to use that water to grow things, it has a knock-on environmental benefit, assuming you do it correctly, where you're putting organic matter in the soil, you're putting resources in the soil, and even though you don't want that to go into the food chain, you're going to create a knock-on effect where proximate areas are going to have a microclimate change effect, and it's going to make it easier for somebody else to grow food not too far away, within 100 meters or something like that. And if you space it correctly, you actually could do that on a pretty systematic basis, and I think that's pretty exciting. So, the real, and by the way, what we call this marrying of fossil resources and renewable resources, hybridization. So we're hybridizing, we're creating a hybrid of fossil and renewable, and we're doing it in such a way to do what is absolutely optimizing our energy inputs, and likewise on the water. And that means that what we might do today might be fairly modest, but it means we're also getting ready for if the prices of solar and other renewable resources continue to come down, that it could be quite large. And then that means that you're really creating an optimal situation where the fuel or the power source that is the best use is going to the best use, right? I'd like to talk a little bit more about, and then there's one other thing, and I had talked about sort of the optionality, but I'd like to talk about the opportunity. And the opportunity starts to be that you actually start to create much lower carbon fuels. And you also start to create, follow-on businesses, which, hopefully some of them will actually be quite valuable, although they may not be businesses that you yourself as the asset holder are that interested in. But nonetheless, end up with a piece of. And that's not necessarily a bad thing. It can be divested over time once it's reached maturity. And so that is also a sort of interesting thing that starts to happen. The last thing I'd like to talk about, I guess I have 7 minutes left, so I want to leave a few minutes for questions if there are any. The last thing I want to talk about is the relationship to what we call in-country value. So, most companies, big companies, try to make an effort to employ, local people, to have a graduate program, and for very good reasons. This diversity helps the company be a better company. It also helps them develop a pool of great managers who can manage, very in a culturally relevant way, but also can bring, their expertise and their culture to the, headquarters of the company and help the company have a broader perspective. But also, not unimportantly, it gives something back to the country. And, ICV programs vary from just recruitment programs to, Shell does a lot of local sourcing. We try to do procurement so that we stimulate small companies. We bring in contractors. We have all kinds of programs. One of the good ones, or the key ones, is there's, for example, in Oman, a lot of people who want to own trucking companies, and so we use local trucking companies. It varies. I've spoken to Anglo-American on this. They use a lot of mid-sized companies to stimulate small company use and so on. But what I'd like to say about in-country value is what I find particularly exciting about this optimization is that I think, because so much of it is really high-tech stuff, it has the potential, if we can make it happen, to add in-country value on a whole new level. So that you're not just doing procurement and encouraging local people who want to have a company and have a good book of business. You're actually doing the right things to stimulate technology hubs and technology clusters in some of these areas, so that if you're going to end up buying, I don't know how many gigawatts of solar in a country, you're going to end up with a whole industry of solar installation and potentially, manufacturing. And what that means is the knock-on is that there may be a research lab, there may end up being locally some real expertise around the latest innovations in solar or wind tailored to that country, solar that's, pretty robust under high heat conditions, that, has special coatings and materials. And I think that's incredibly exciting. And I think there's a real opportunity for partnership between countries where we have a glut, frankly, of qualified people who are looking for really exciting opportunities, experienced entrepreneurs, finance, and countries where the opportunity lies. And by coming together, we can actually, start to create technology clusters and hubs in a whole new way. And I think that's very exciting because, frankly, it's not just, for example, Saudi Arabia, who gets poor guys get a lot of bad press for their youth unemployment problem. Frankly, if you look underneath the numbers, the US has a youth unemployment problem. Spain has a massive youth unemployment problem. The UK mitigates their youth unemployment problem by sending a lot of people to school. But this problem is worldwide. And so we need to find exciting opportunities for our young people and a methodology for leadership, and I think we can do that together. So I'm just going to stop there. I think there's a few minutes for questions, but I'm really excited about this idea, and I hope you are too.
Right. Thank you very much, Anna. Any questions?
Thank you very much for a very nice presentation. So my question is, as you mentioned, this is a very good idea that you dump the saline, highly rejected saline water from desalination industry to your oil field. But of course, the oil field and the desalination plants are supposed not to be very near together. So who is going to bear the cost for the...
Good question. I don't have an answer. I mean, in some cases, we've looked at, we have taken Google Maps and done tick, 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 how far is it and what is the cost per kilometer of pipeline. And, we wouldn't be talking about it if we didn't think it was doable. But, no one company, no one government is going to pay for that. But the good news is that if you look at the entities that are in, these oil facilities, it is a group of, a number of shareholders, and it's a substantial cost. But, there's probably some money from the government, and there's probably some money from a bunch of equity holders. I don't have a solution, but I think it's in the realm of the doable, so we should have it in our minds as one of the things we should think about. But, this is a problem with all infrastructure, by the way, is that whenever you do evaluations of infrastructure, like putting in a train line or something like this, or moving to high speed, it's very difficult based on what we tend to project today to justify the cost of that, but we know that things like putting in train lines completely revolutionize and change how people move around and how they even build their houses and how towns and cities are built. And so we know it actually has a knock-on effect and a benefit that's much, much greater than what we can imagine. And I suspect that, environmental things like this are quite like that, in the sense that I can't put a value on the crawfish that's sitting in the mangroves that's suffering today, but probably the knock-on benefit is very significant.